wanted to go ahead and do a video wrapping up the last two questions that we were talking about in class today. If you don't have your packet with you, please go ahead and pause the video and get that grabbed and open up to the appropriate page. And once you're ready, let's get to it. While tax tables and the tax rates work well for calculating tax for a single individual, a business might want to create a spreadsheet that automatically calculates the tax for an individual based on their taxable income. To do this, they need to write a formula. So we're going to go ahead and identify T is going to be the amount of tax owed. We are going to say that the variable X is going to be taxable income. And we're also going to say, and this is going to be saved for number 9 on our page, W is going to be wage income. Okay. So number 8 says, assume that we're only interested in couples with taxable income between $18,150 and $73,800. So if you recall, we can kind of go ahead and write that out as a compound inequality. We are basically saying that we want our taxable income to be between two values. One of them would be $18,150 and $73,800. So please note that I chose my inequality symbols deliberately. Notice that if you were to cover up the $18,150, we're saying that our taxable income, or X, has to be less than $73,800. If you cover it up in the other direction, it's basically saying that $18,150 has to be less than X. If you kind of flip that and reverse it, we would say that our taxable income has to be greater than that amount. So basically I'm saying the same thing, just in two different ways. So from what we can do here, we want to go ahead and write an equation that will take taxable income X and compute the tax T they owe. So if you refer back to that chart that we had used to help us answer number 3 of your lesson, we find out what kind of instructions we have to work with. And I'm actually going to go ahead and write it in purple underneath this compound inequality here. So if our value is between these two dollar amounts that I have written in blue, we know that we have to pay $1,815 straight away. This is a flat fee that we must pay. Plus, we have to do 15% of the excess over $18,150. Okay? So actually, the way that we have this written, and I kind of revealed it already, the formula that we are asked to create is actually staring at us, but it's buried underneath these words. We can go ahead and distill it down to mathematical symbols. So first off, I know that I'm paying this flat fee here that I'm boxing in orange. So I do know that I have to pay $1,815. Then I also know that I'm going to add something to it. Okay, hence the reason why they said plus. So we've been using the word plus to describe addition probably since we were in elementary school. 2 plus 2 is 4. 1 plus 3 is also 4. Apparently I'm just stuck on an example that makes you have it equal out to 4. So the next thing that we are going to do is go ahead and notice that we're going to do 15% of something. So that does tell me that I'm going to work with 15% and that I'm going to do a multiplication. And I'm actually going to just do this overly emphasized bolded dot. I don't actually want to write an X here to represent multiplication. If I do that, then basically what you could be doing is potentially confusing your reader to the point where they're going to say, does that X represent a variable or does that X represent multiplication? There's really no way to tell them apart. So we use a dot to indicate multiplication here. Another talking point is to remember that if you are working with a percentage, we want to locate that decimal and kick it back 2 places in order to have it written, have our percentage written as a decimal to give us an appropriate calculation. If we left this as 15, we basically would be telling someone that they would have to pay 1,500% of the excess that they're going to be paying. And we obviously don't want to charge someone 1,500% of something. It won't be pretty for them. So the last thing that we want to do is we want to talk about the excess that we're seeing here. Well, in order to figure out the excess, remember that what we did was we took our taxable income and we subtracted it from that $18,150. So very similar to what we had done in question 3. And we're going to go ahead and do that here. I don't know what my taxable income is. They've just provided me X as a variable. And we use a variable because we're basically saying that this value could change at any point in time, or we could put a bunch of different values in there and still be okay. So I don't know what my taxable income is yet, so I'm just going to put X in there to hold its place. And I'm going to subtract that from the 18,150, and that's going to give me my excess. When all is said and done, this is going to give me the amount of tax that I owe. So this is part A that we've solved for. Part B is asking us to go ahead and basically just simplify everything up. So in order to do that, we would go ahead and note, well, I have a multiplication here, and I'm multiplying it by something that's been grouped. And when I say that something has been grouped, I'm basically saying that they have parentheses around it. What we want to do is utilize the which property starts with the D. Hopefully we're kind of doing the Sesame Street Dora the Explorer Nick Jr. thing. So you, at this point, you're hopefully screaming distribution, maybe like that, or maybe just think it, just in case you have people around you who are listening. So we're going to go ahead and we're going to distribute that 15% to each of those terms. So X being one term and that 18,150 being the other term. So what we have here as a result will be $1,815 plus 15 hundredths times X minus 15 hundredths times 18,150, which ends up becoming $2,722.50. This is equal, again, to our taxable income. I basically have just used the distribution property. The last thing that I want you to note, though, is that I do have a constant and another constant, so I can go ahead and combine like terms here. If I do that, then I will get the following. I will get 15 hundredths times X minus 907.5 is equal to T. If you were working through this and you got the following, so a negative 907.5 plus 15 hundredths times X, that is perfectly fine. You basically just swapped the positions of these numbers. So please remember, like kind of a simple example, if I did 5 plus 7, that's equal to 7 plus 5. This is your commutative property. You are allowed to switch the positions of the terms around. You just want to make sure that the sign that is in front of a number, whether it be positive or negative, follows it, okay? So for example, I wouldn't want to say that this is going to ever be like 907.5 plus, or sorry, minus 0.15 times X. I want that negative to stay with the negative 907.5. Okay? So here is two possible ways to present your final answer. Okay? So number 9, and I will go ahead and bring that back for you, or go ahead and just rewind it and freeze the screen. So number 9 says, assume also that we're only interested in couples who fill out a 1040 easy and only have wage income. So we want to write an equation that will take their wage income, W, and compute the tax, T, they owe. So in this instance, let's recall what wage income is. Okay. So we know that wage income, from the very beginning, we wanted to note this as the variable W. Okay. So wage income refers back to the very first question in your lesson. Okay. Wage income is going to basically be what we've pulled in from wages, so it's that line 1. Okay, so in our first example, we said it was that $93,000 that couple had earned in wages, okay? So if we don't know what the wage income is, we still are able to kind of recreate what we had done all the way back in, let me think for a second, number 5, when we were talking about the bonus. So we know in order to find X, in other words, our taxable income, we are going to take our wage income and subtract $20,300 from it. So what we've done was we've gone ahead and taken a variable that we've worked with previously, X saying our taxable income, and now we're actually taking a step back further. So instead of working with taxable income, I'm going to start by working with the wage income. Okay, so the wage income minus the $20,300 in this situation will take me back to my taxable income. Hopefully the descriptions that I'm using aren't sounding too clumsy and it's not falling over itself or repeating itself. But basically now what I am allowed to do is I can take my previous equation that I have highlighted in pink here and just really quickly note something. I'm going to use red here. So if X is equal to this description, X is the same thing as W minus 20,300, look where this can go. This, hopefully everyone is just going, what? This is amazing. This, you can use substitution. In other words, if I know that one item is equal to another, I can go ahead and swap those items out. Okay, it's like baking. Maybe sometimes you can substitute coconut milk for regular milk or something like that in a recipe. So what I'm going to go ahead and do, I'm going to note this in purple below, is I can take my 15/100ths times, instead of X, I'm going to drop this in. X is the same thing as W minus 20,300. Cool, I can do this. Minus 907.5, and that is going to be equal to my taxable income. So think about what I've done here. I've actually taken what I've created in number 8, and I've taken it a step further. So this way, my clients in this situation, because we are supposed to be acting as the business owner in this situation, maybe at an H&R Block or something like that, we're basically saying that my client doesn't have to come in and tell me what their taxable income is. They just have to come in and tell me what their wages were, which is probably something easier and more attainable for them to grab and quickly give to you, as opposed to them sitting down and figuring out what their taxable income is. So now I can go ahead and clean this up a little bit further. Okay, so here is your solution for part A that I've boxed in purple. Yes, so now we can go ahead and we can clean this up further, because if you notice, and I'm going to try to highlight this in like a burgundy here, I have grouping. I have a grouping, so I have parentheses again. So as we had done previously in part B, I can go ahead and distribute this. So I can give W, I can have that be multiplied by 15%. And I can also multiply my 20,300 by 15%. So what this will do, I will go ahead and I will write this in blue. So we have 15% times W minus, and then again if we do 15% times 20,300, we get 3,045. So the parentheses go away since I've distributed, and I can write everything on one line and have it wide open. Note here that I do have a constant value and a constant value, so I can go ahead and combine like terms in this situation. So now I have 15% times W, and this will be minus $3,952.50, and this is now going to be equal to my taxable income. Okay, So what I have circled in green should be your solution for part B. Again, just to kind of hammer this home, if you said, well, I got t is equal to negative $3,952.50 plus 15% times w, you are absolutely correct. You can check this by, coming up with some sort of value for your wages. Obviously, you would want to pick something. Let me scroll up a little bit. You want to pick something within this initial compound inequality, because that's what we've been working towards. But after that, you would see whether you used this equation or this equation, or sorry, not the first one that I checked, but the bottom one here, you would get the same taxable, same amount of money that you owe in taxes. Okay? So I hope that helped. If you have any questions, please stop and see me, or go see your embedded tutor.